Thanks, Jay and Ewan. Now it's time to get hands-on. I'm Leah Kaplan, and I'm a customer engineer with Google Cloud based in Perth, Australia. Today I'm going to take you through a great lab on AutoML vision. Details on how to access the lab were shared in the reminder email sent yesterday and can also be found in the FAQ tab above. We'll also send a follow-up email with all the details at the conclusion of this week's program. I'm going to move through this lab quite quickly, but don't be concerned about keeping up. This session will be available on demand in a few days for you to watch again and try the lab at your own pace. If you have any questions along the way, please feel free to enter them in the text box below the video. We have Google experts on standby to answer your questions live. Before we dive into the lab, let's get a quick overview of Google Cloud's machine learning offerings and where AutoML fits in. Our Smart Analytics vision at Google Cloud is to create a radically simple to use, intelligent data platform that provides actionable insights in real time to drive digital transformations across enterprises. To do that, we want to meet you where you are on your analytics journey. We have services that span the range of expertise and customization needed. On the low customization end of the scale, we have our pre-trained models that you can call via API. As it sounds, you don't need to train them or really have any ML expertise to use them. You may already be using them, in fact. If you are using Google Photos and it tags landmarks in your pictures, that's the Vision API. Or if you hold your phone up and translate a sign or a menu automatically, that's Translation API. Those commercial models, trained on a massive amount of data and maintained by Google, are available to use within Google Cloud Platform. At the other end of the spectrum, we have tools to build fully custom models. AI Platform is our fully managed end-to-end machine learning and data science platform. We support popular frameworks such as TensorFlow, PyTorch, scikit-learn, XGBoost, and many others. We have pre-built deep learning VM and container images that are ready for you to use. And you can accelerate your training and inference by adding GPUs and TPUs. TPUs, if you haven't come across them before, are tensor processing units. These are custom designed chips for machine learning that can speed up your training by as much as 27 times. But today, we're going to focus right here in the middle of the spectrum for users with the domain knowledge to solve the problem, but not necessarily deep machine learning expertise. For subject matter experts that know SQL, we have BigQuery ML, which allows you to train, deploy, and make predictions against your models only using SQL. It's one of my favorite features. You may have seen my colleague Russell's presentation on BigQuery ML yesterday. It's definitely worth checking out if you missed it. And then we have AutoML. As you can see, we have an AutoML analog for most of our pre-trained APIs. AutoML is designed for domain experts to work on what were formerly really challenging machine learning problems without having to be an expert. So with it, you can build and deploy a high-quality custom ML model with minimal effort, as we'll see today. All you have to do is provide your training data, and we automatically take care of the remaining steps to deploy a high-quality model into production. So let's set the scene for the hands-on lab today. Let's imagine that we are meteorologists whose job it is to study the weather. I want to use images of clouds to automatically identify weather patterns and the impact that they might have on flight schedules. So what do I need to know? Well, there are at least 10 different types of clouds that I need to identify, which indicate all different weather conditions. What can I use to help? I might try the standard Google Cloud Vision API, and you can see it does a good job of identifying things in kind of a generic way. It says sky and cloud and blue, but it's not specific enough for my purpose. I need to know exactly what type of clouds these are. And that's where we have AutoML Vision to the rescue. You'll find the lab instructions at this link. Everyone attending these sessions will have 30 days of free access to Quick Labs, so there's no need to keep up with me as I go through it. You can go through at your own pace later. In fact, you'll notice that this lab has 2 hours allocated to run through it. A lot of that is for training and deploying the model. Watching that happen would be about as exciting as watching paint dry. So instead, I'll jump to a model that I trained and deployed earlier at that point. Okay, let's get started. I'm going to click Start Lab because that takes a minute to start provisioning all of the resources that I need while we talk about what we're going to do today. So in this lab, we're going to upload images to cloud storage to train our model. We'll also upload a CSV file with the labeled images, and then we'll connect it to AutoML Vision. Then we'll train the model and evaluate its accuracy, and then generate predictions against the trained model. Right. So if you haven't used Quick Labs before, it's really important to know that you get generated a new project and user account every time, and it uses the credits associated with that account. So when we open the console, please make sure you do it in an incognito or in private browsing window so that you don't accidentally get charged against your account. All right, so let's do that. So I'm going to click open console, and I'm going to do that in a new incognito window. And then I'm going to copy the username and password that's provided. And click accept. There's no need to protect your account because it's going to be destroyed as soon as we shut down this lab. And the last thing it's going to ask me to do is accept the terms of service. Okay. And we've done all that. So the first thing that we need to do is enable AutoML Vision API. By default, services in Google Cloud Platform are disabled, and you need the correct IAM permissions to enable them. And that allows your organization to decide who can have access to which services and who can enable and disable access. For this lab, you have the right permissions to enable the services, so let's do that. So let's go to the navigation menu, which is up here, and go to APIs and Services, and click on Library. And then I'm just going to search for Cloud AutoML. If I click on Enable, then in just a minute, that API is going to be enabled for this project. Great. Okay. Now, the next thing that we're going to do is activate Cloud Shell. Now, Cloud Shell is an interactive shell environment that we run for you in Google Cloud. It makes it really easy to manage your projects and resources right from your web browser. So let's start that up. The button for Cloud Shell is up here. If I click on that, it's going to take just a minute, and it's going to prepare a little VM for my use. Now we're going to use Cloud Shell to assign ourselves the right IAM permissions to use AutoML and to create a storage bucket for our project and copy the images and CSV files with labels across into our storage bucket. Let's see if I can make that bigger. So that you can see it better. Okay. So the first thing that we're going to do is save our project ID in an environment variable because it's just long and kind of painful to type. So I've now done that. If you ever need to check if your environment variables are saved correctly, you can just echo them and see what's been saved. And yes, that's correct. The next thing I'm going to do is create another environment variable for the Qwiklabs username because, again, it's just not very user-friendly to type. So let's save that. And now we're going to run a command to give ourselves AutoML permissions. So using the gcloud projects command, we're going to add a policy binding for this project, which is the one we just typed in, and the user is ourselves, and we're giving ourselves the role of AutoML admin. You'll get a pop-up that asks you to authorize the fact that you're making an API call, and that's fine. That's what you should be doing. That should just take a second. Okay. The next thing that we're going to do is create a storage bucket in order to store all of our files. So let's run that command. So we're going to run this gsutil command. Gsutil is the command line to interact with Google Cloud storage buckets. So MB for make bucket, -P is for the project that we're looking at, which is our project in this case. -C tells you which storage class. We're going to use a standard storage class. -L is the location. We're going to put it in US Central 1. And then finally, you give it a bucket name. A good thing to know is that storage bucket names have to be globally unique. That means no one in the world can have the same storage bucket name as you. It doesn't matter which project it's in. A good hint for creating a globally unique bucket name is to use your project ID because project IDs are also globally unique. So let's do that. And there's something going on with my resolution. I can't see it. But that has worked correctly. Okay. Now we can go into the console and check and make sure that that has worked correctly. So if you go to the navigation menu, and you scroll down to storage and go to browser, you'll now see that we have this storage bucket. Great. Okay. So the next thing that we're going to do is upload all of the training images to Google Cloud Storage. So I'm going to create another environment variable for the bucket name that we just created. Let's try that again. Having some issues with the resolution. Okay, so I've exported the bucket name. It's just not happy. Okay. And then I'm going to copy the files across using the gsutil command again. So let's do that. These are actually stored for you in a storage bucket that Google is maintaining. So the gsutil command and then -M for multi-threaded, the copy command -R for recursive. So get all of the files that are in the subfolders and copy them into our bucket. And that's running across our internal network, so it should be done in just a second. Yep, all done. Now, if I go into my storage bucket, I should see all 3 folders, which is what we would expect, and the files in each of them. And if I click on one of these files, I can see the metadata associated with that image and also a preview of the image itself, which is quite handy. Okay, the last thing that we're going to do is fix up the file that has the image labels in it. which we've also created for you, which is quite handy. So let's use this gsutil command again to copy the file from that public storage bucket to our local machine. And that's done. Now let's just have a quick look at it. What you can see is that it's got placeholder instead of the bucket name that we want. So it should have the URI of the file and the label, and we just need to fix this up quickly. So we're going to substitute in our bucket name where it says placeholder, and we're going to use the sed command to do that. And then if we check the file again, you can see that this looks correct now. It's got the actual bucket name that we want and the label for each file. Great. So the final thing that we need to do then is copy that file from our Cloud Shell machine up into our storage bucket. Again, using the gsutil command, we'll copy that to our storage bucket. And then if I go back to my storage bucket here, you can see that I now have the CSV file and we're ready to begin creating a data set in AutoML Vision. Now I no longer need the Cloud Shell, so I'm going to close that. And now I'm going to navigate over to AutoML Vision. So it's down at the bottom in artificial intelligence. I'm going to go to Vision and Datasets. And we're going to create a new data set. Let's name this something reasonable like clouds. And then I get to choose my model objective. In this case, we're going to do a single label classification. That means each image just has one label associated with it. You can also play around with a multi-label classification. So one image can have multiple labels, or you can do an object detection in your own time. Those are all fun to play with. As I mentioned before, you could upload images directly from your computer and label them, but we've already done all the hard work for you. We have a CSV that has the labels for all the files, so let's use that. If you happen to remember the name of your file in your storage bucket, you can type it in, but it's just as easy to browse to it. And click Select, and then Continue. And it's going to import all of the images for you into AutoML Vision. Now this will take between 2 and 5 minutes. So we're going to take a quick break while this imports and come back in just a minute and continue. Okay, and we're back, and you can see now that all of the images are imported. It should look something like this. You get a nice overview of the labels also. So I can see I've got 20 labels, 20 images for each of the labels. I can click in on any of these images also. And if I need to, I can change the assigned label right here in the console. I can click on label stats also to get an overview of the same thing. So I can see I've got 20 images for each label. And what you'll also see is that AutoML has already split this into a training, validation, and test set for each. These are quite low numbers. If you were going to do this with your own project, you'd want to have at least 100 images for each label. But we wanted to make it quick and easy to train, which is why there's not very much data in here. Okay. So we've done all this. We've inspected the images, and we've looked at the stats, and now it's time to train your model. This is very easy. So in the console, all I need to do is go to the Train tab, and I click on it. And I get that same image that I got before about the image stats, and I click Start Training. I only have 2 questions that I need to answer. So where do I want this hosted? Do I want to host it in the cloud and make online predictions against it? Or do I have an edge use case? Do I want to be running this somewhere where I won't be connected to the internet and I want to put it on a device, maybe a phone or maybe an edge TPU, and do inference there? In this case, we're going to run it hosted in the cloud, so I can leave that. And the other question is, how long do I want to train this for? Now we're going to set this node budget to 8 because this is just to learn. We do give you a recommendation, and if you hover over where it says 16 node hours, you can see how we've come up with that. So we have less than 1,000 images, actually way less than 1,000, so we've recommended 16 node hours, but you can do obviously huge numbers, and we can handle that quite well. And that's it. So I'm going to click Start Training, and that's going to take about half an hour to train. Again, this would be pretty boring to watch, so we're going to take a quick break here while I show you one that I trained earlier. Thank you. Okay, at this point you're back because your model has finished training, and let's look and see how it did. So let's click on the Evaluate tab up the top, and you can take a look at the precision versus recall. If you've trained other models, you notice this looks a little strange. It's because we have only 6 test items, so the curve is a little bit sharp. You'll also notice the confusion matrix, which gives you a very good overview of how your model performed on all the different labels that you have. So you can see for cumulonimbus, it got all of them correct, and same with cirrus. For cumulus, it identified half correctly as cumulus and half correctly as cumulonimbus. Again, very small test data set, but if we were doing this in real life, that might indicate that you need better training data going forward. But let's assume that we're happy with this and we're ready to use it. So the next thing that you would do is deploy. So you click over on the Test and Use tab and deploy your model. Now that takes about 20 minutes to deploy. Again, nobody wants to sit through that. I've already deployed mine, so let's take a look at what that looks like once it's deployed. Right, so I have multiple options for testing this right here in Google Cloud Platform. I can use the REST API to test it. I can use Python, or I can just upload images and test them right here in the console. So we have given you a couple of images to use for testing. You can also download images off the internet if you'd like and try that, but you can right-click these images and save them to your computer. And then you can upload them right into the console. These are the 2 images that I selected. If I click Open, it's going to immediately give me predictions on them. So the first one, it is 98% confident that this is a cumulonimbus. And the second one, it is rounded up to 100% confidence that this is a cirrus cloud. So that's great. So that's the end of this lab. You have finished. You've learned how to train and deploy a high-quality image classification model with no code, and how to make predictions against it in the web console. So that's it from me. I hope you found that lab walkthrough helpful and ready to tackle it yourself. Remember, you can find the details to access the lab in the FAQ tab at the top of the page. You might also like to try out our other on-demand labs listed in the Dev Zone menu. If you know someone else who would benefit from watching this session or any of the sessions today, it's really simple to share it with them via the link on the program on the homepage. All of our cloud technical series will be available to watch again on demand in a couple of days. And that wraps the final day of our cloud technical series. Thank you so much for joining us. Feel free to continue the conversation and tag us with hashtag Google Cloud Tech Series on social media with your thoughts of the program. Stay safe and see you next time.